Today's lesson is on equivalent fractions and multiplication. Students will find equivalent fractions using multiplication. If you have not previewed the vocabulary for today's lesson on your Power Learning, please do so now before you begin this lesson. You need to know what the word equivalent means. So let's jump right in. We're going to begin with breaking all the parts into two equal parts to create equivalent fractions. So a parent and a child were sharing a cake. The parent divided the cake into two pieces. So pretend this is the first cake. The child wants two pieces, so the parent cut the cake again and gave the child two pieces. So this is what the parent started with, and this is what the parent ended with. So they cut it again into half. Did the child get more cake by getting two pieces? No. We know this because originally we had one half of cake. So parent would have got this side, child would have got this side. Child said, Mom, I want half, or I want two pieces. So the parent cut it in half, the child got two pieces. So now the cake is cut into 2/4. So the child didn't actually end up with more cake, just instead of one big piece, they got two small pieces. These fractions are equal because the picture has the same amount shaded. And we can also know that the numerators and denominators are related through multiplication. All we did is we took this one and we times it by 2, and we took this 2 and times it by 2 as well. That gave us the 2/4. So both people get twice as many pieces, but the same amount of cake as they were getting before. So you're going to copy these shapes onto your whiteboard. You're going to break each part in half to create equivalent fractions for the shaded part. You're going to write the fractions on your whiteboard, not in your notebook. So we're going to first do A together. So we're starting with this shape. We're starting with 1/3 shaded. I'm going to copy it out onto my whiteboard like this, and I'm going to cut it into half. So I've started with 1/3, and then when I cut it into halves, I now have 2/6. I want you to complete B, C, and D on your whiteboard by cutting them into half and then resume your screencast. Great job. So you have found all of your equivalent fractions for the fractions that you were given by cutting them in half. So now we're going to look at these pictures. I want to know how many times as many parts the first picture has as the second picture. So for this first one, we know that the first picture is cut into 1/8. This picture is cut into halves. So how many more parts does this one have? Well, it has 4 more parts. We know that because if we take the 2 that this part has and we multiply it by 4, we get this part that has 8. Now, if we look at B, it has 6 parts. This has 3. So how many more parts does it have than the other one? Well, it has 2 more, because if I take the 3, I multiply it by 2, I'm going to end up with my 6. If I look at C, I have 6 and I have 2, so this is 3 more parts than this one. I started with 2, I multiply it by 3, and it's going to give me my 6 parts. Now if I have D, I have 3, 6, 9, 12 parts in D, and I have 3 parts in the second one. So how many more times is this one? Well, if I take it and I multiply it by 4, it's going to give me 12. So this has 4 more parts than the other half. Now we're going to look at the shaded parts. So now I have the exact same pictures and I've shaded them. So if I have 1/2 shaded, and now I have 4/8 shaded, what did I multiply the numerator and the denominator by to get this? You're going to find, just like when we looked at the first time, it's still 4 times as many. So if I took the 1 and I multiplied it by 4, took the 2 and multiplied it by 4, I'm going to get 4/8. The same will be true for all the other examples that we've already looked at. So because all the parts were divided into the same number of parts, the shaded parts were also divided into that number of parts. So nothing's changed. So I want you to now write the equivalent fractions for these pictures on your whiteboard. Let's do A together. So for A, we have 4/8, and we have 1/2. These are known as equivalent fractions. They are the same pictures shaded. Write out the equivalent fractions for B, C, and D on your whiteboard, and then resume your screencast. So in equivalent fractions, both the numerator and the denominator are multiplied by the same number when we're trying for equivalent fractions. So we can see that 1/2 was times by 4, numerator and denominator, to get 4/8. They have to be multiplied by the same number. This is the most important thing. It has to be the same number. So we can use a single picture to write two equivalent fractions. So look, you can look at the big parts or you can look at the small parts. The big parts, so when I say the big parts, we're looking at this being one part here and this being another part, the non-shaded region. So we can see that this is showing the equivalent fractions of 2/3 because this would be 1, 2, 3. And 2 of them are shaded, the last third is not. We can also look at it, so if I take this highlighting away, we can also look at this in what we call the smaller parts. So if we look at just one cube as one part, so like let's say this is 1. So how many cubes or squares are in this picture? Well, we have 12 squares all together. And how many of those are shaded? Well, 2, 4, 6, 8. So we can say that 2/3 is equal to or equivalent to 8/12. Now, we could also look at it in a third way. So we could also say that this is equivalent to looking at it as this way. So if I say this is one part, so 1, 2, 3. No, sorry, that doesn't work. Ignore what I was just about to say. We're going to move on. So here, I want you to look at these shapes in two different ways, and you're going to write equivalent fractions for this picture. So let's do A together. So first, we could look at this as 1/3 being shaded, because one of these columns is shaded, 2 are not. And we could also say it's equivalent to 2/6, because there's 2 blocks shaded and there's 6 in total. So write me equivalent fractions for B and C on your whiteboards and then resume your screencast. Here's a bonus. Let's see how many equivalent fractions we can make for this picture now. So let's start with A. Let's do A together, and then you're going to try B on your own. So we can say that A has 2/3. There's 2 columns shaded, 1 is not. It is the same as saying 4/6. So 4/6. So we can say that if 4/6 works if we look at it in this square. So 1, 2, 3, 4, 5, 6. So 4 of those little blocks would be shaded, 2 are not. Then we can also say it's equal to, if we look at each block individually, it's equal to 8/12. I want you to do B and then resume your screencast. So if we use multiplication to write an equivalent fraction, let's look at this picture. How many parts do I have to break each piece into to get 12 parts all together? So I'm starting with 2/3. So how do I get 3 to 12? So what is 3 times what would equal 12? Well, you should be able to tell me that 3 times 4 equals 12. And remember the rule, what you do to the denominator, you have to do to the numerator. So what is 2 times 4? Well, 2 times 4 is 8. So you know that 2/3 is equal to 8/12. Now, I want you to show me how to do this on your whiteboard. So we're going to multiply to find the missing numerator. Let's do A together first. So think of it in terms of 5 times what gives me 15? Well, 5 times 3 gives me 15. What you do to the denominator, you have to do to the numerator, so I have to times that by 3 as well. It's going to give me 3/15. So 1/5 is equal to or equivalent to 3/15. Once you have finished B, C, and D on your whiteboards, you're going to resume your screencast. There's also a bonus down below here that you can give a try. So we know we can make equivalent fractions using multiplication, but we can also do it by skip counting, because skip counting and multiplication is the same thing. So here showing you how to get equivalent fractions by skip counting. So if I have 3/5, I'm going to skip count to get the next equivalent fraction. So if I skip count by threes, 3, 6, 9, 12, 15, and then on the bottom I'm going to skip count by fives. So 5, 10, 15, 20, 25. These fractions would all be equivalent. So we know that this one is twice as many parts. This one is 3 times as many parts, 4 times as many parts, 5 times as many parts. That's why skip counting works. So we're going to try this. We're going to write 4 equivalent fractions to 2/5. So if I start with 2/5, I know that I can skip count to find the next equivalent fractions. So I'm going to go 4, 6, 8, 10. Now I need to skip count by fives on the bottom. So 10, 15, 20, 25. So these fractions are all equivalent to 2/5. They're all the same. So now let's look at this picture. So we're going to find equivalent improper fractions using multiplication. So what is the improper fraction for this picture that I'm showing you? Well, we have 1, 2, 3, 4, 5, 6, 7 pieces shaded. Okay, and we have 2, everything's divided into 2, so our denominator is 2. Now we're going to have each part, so we're going to cut each part into half to have this. So what is the equivalent fraction here? Well, we have 4, 8, 12, 13, 14 pieces shaded, and each piece is now divided into 4. So we have 7 halves is equal to 14/4. So this is what it would look like as an equivalent fraction. We multiply the numerator and denominator of the fractions by the same number. So we multiply the numerator and the denominator by 2 in this case. So here's some exercises for you to try on your whiteboard with improper fractions. So 5, now you're going to work backwards. 5 times what gave you 10? Whatever this is, so obviously 5 times 2 gave you 10, you have to do to the denominator as well. So it's going to be 6. Do B and C on your whiteboard and then resume your screencast. For your activity today, you're going to complete your jump pages 151 to 153. If you're finished early, there is, on your Power Learning, there's a game. There's 2 games that you could play with a partner to work on your equivalent fractions and multiplication.